The focus of this lesson is on finding the horizontal or oblique asymptotes of a rational function. So we're going to start off with the function f of x equals x squared minus 4 divided by x squared plus 5x plus 6. In order to determine the horizontal asymptote, what we need to do first is we look at both the numerator and the denominator and look for the highest power of x that we see. And we can see that the highest power of x that we see is degree 2. So the way we would handle that is we would take our function and we would take every single term and we would divide it by that highest power of x. So in this case, x squared. So x squared divided by x squared minus 4 divided by x squared, and then take the denominator, the x squared divided by x squared, the positive 5x divided by x squared, and the positive 6 divided by x squared. So again, you can see we've divided the numerator and the denominator by that highest term, x squared. And so then what we do is we basically have a bunch of little fractions that we could cancel down or reduce down to lowest terms. So we know that if we have a numerator and denominator that are identical, they divide out to be 1. But if we have a case where we go to do division and we're left with an x in the denominator, well, I'll just kind of show that for now. So we're just kind of leave this. We could see this. This is as simple as it gets. And then x squared divided by x squared is 1, plus 5x divided by x squared is just 5 over x. And then 6 divided by x squared doesn't reduce any further. So we can see that after canceling out the common factors that this is what we're left with. Well, anytime there's an x in the denominator, since we are talking about a horizontal asymptote, we're thinking about the x going to either positive or negative infinity. And so it's either a really big number or a really small negative number. And so whenever you take a constant and you divide it by something really big or really small, it goes down to 0. And so all these terms that have an x in the denominator go to 0. So we're going to actually replace those terms with 0. And that's always the case. So we can see that we're left with just 1 minus 0, 1 plus 0 plus 0. And so the result is just 1 over 1, which is 1. So the horizontal asymptote is y equals 1. And that's a horizontal line that goes through 1. We're going to go ahead and take a look at a second example. So we're going to look at the function f of x equals x squared plus 2x plus 3 divided by x cubed plus 2. So again, we're going to look at both the numerator and denominator and look for the highest power of x. And so we can see that the highest power of x is x to the third. So we're going to take every term and divide it by x to the third. So x squared divided by x to the third, 2x divided by x to the third, 3 divided by x to the third, and then do the same thing for the denominator. We got x cubed divided by x to the third, and we got 2 divided by x to the third. And then what we're going to do is we're going to reduce all of those fractions down. So in the first fraction we're left with 1 over x plus 2 over x to the second plus 3 over x to the third. And then in the denominator, we're left with x cubed over x cubed is 1 plus 2 over x to the third. And so you can see that any term that has an x left in the denominator should go to 0. And then obviously this constant 1 stays. And so we're left with 0 divided by 1, which is 0. So we were left with the line y equals 0. That's our horizontal asymptote for this function.